Number 52. If a cylinder contains 10 grams CO2 in 10 liters at 325 Kelvin, what is the pressure? This is an ideal gas law problem. Now we're told the mass of the gas, but if we know the mass, we can always convert to moles. So if you know the mass, you really know the moles. So we know the moles, or we can figure out the moles. We know the volume, and we know the temperature. And the ideal gas law says that, you have 4 variables in here. You see 5, but the gas constant is always the same. So if you know the temperature, the moles, and the volume, you always know the gas constant. You can solve for the pressure. And solving this equation for the pressure, here it is. So we're going to have to plug in the moles, the gas constant, the temperature, and the volume. The only thing we need to figure out first is the moles. We have everything else. So the moles, we need the molar mass. So using the formula CO2, we got 1 carbon, 2 oxygen. So 1 times the atomic mass of carbon, 2 times the atomic mass of oxygen. And here's carbon and oxygen just to show you on the periodic table. So carbon and oxygen. Okay, so plugging in those values and adding them up, you get 44.009 grams per mole. So to get the moles, you take 10 grams times 1 mole is the same thing as 44.009 grams, and that gets you moles. It's 0.2272 moles. So now we have the moles, and we can calculate the pressure. The pressure is going to be moles times gas constant times temperature over volume. So here's the moles. Here's the gas constant that you can look up in the textbook. It's always the same, 0.0821. And the units of the gas constant are atmosphere liter per mole per Kelvin. You plug in the temperature, 325 Kelvin, that you're told in the problem, and also the volume, 10 liters. And you can see the liters canceling the liters inside the gas constant units, the Kelvin canceling the Kelvin, and the mole canceling the mole, and you're left with units of atmosphere. And doing the math, you get 0.60622 atmospheres, which rounds to 0.606.